So now let's talk about lenses. Unlike with curved mirrors, where there were just two basic shapes, with lenses there are more. However, they're basically the same. The first two are the main kinds of lenses we talk about. A biconcave lens has two concave surfaces, and a biconvex lens has two convex surfaces. We normally just call this one concave and this one convex. But the thing is, lenses like these, spectacle lenses, are actually curved on the front and the back the same way. They are called a meniscus. A concave meniscus is basically equivalent to a biconcave lens, and a convex meniscus is basically equivalent to a biconvex lens. To work out what happens to the light, we need to know a little bit about what happens to light rays as they go through these lenses. Light going through a prism always bends towards the thick part of the prism. Now, the reason for this has to do with refraction, which you may not have come across yet. As the light ray enters, let me get a pen, as the light ray enters the prism, it's entering a thicker material and it bends towards the normal. And then when it gets to the other side and re-enters the air, it bends away from the normal. Look at the one on the right. As it enters the prism, it bends towards the normal. Then as it re-enters the air at the other side, it bends away from the normal. And the overall result is that light ray bends towards the thick part of the lens. So if we put this together, a convex lens, really a biconvex lens, converges the light, because the light rays up at the top bend towards the thick part in the middle, the light rays at the bottom bend towards the thick part in the middle. A convex lens is converging. Conversely, a concave lens bends light away from the centre. The light rays coming in at the top bend towards the thicker part at the top, the light rays coming in at the bottom bend towards the thicker part at the bottom, and the light rays coming out diverge from a common focal point. What we're going to do with lenses, just like with curved mirrors, is draw some ray diagrams. We're going to draw in a principal axis, work out the centre of the lens and the focus. We talk about the centre in the same way as we did for curved mirrors as being twice the focus. For lenses, the thing about talking about the focus is, as the focal length increases, the lens actually bends light less. Now, what we'd really like is a way to describe how much the lens bends the light in a way that increases as it bends it more. That would be the lens power. The power is the reciprocal of the focal length. It's measured in diopters, which is just per metre. It's the inverse of metres. This means that a more powerful lens has a shorter focal length. A concave lens, remember, was diverging. So a concave lens actually has a negative power and a negative focal length because the focus is behind the lens. When we draw these, it's like when we were doing ray diagrams with curved mirrors, when we didn't have a compass to draw it. We're just going to draw a simple representation of the lens shape. We're just going to draw an imaginary line vertically through the optical centre of the lens and bend the light rays at that centre line, rather than worrying about the exact shape of the lens. The three rays we're going to draw are exactly the same as we did with curved mirrors. The third one's slightly different. The first ray goes in parallel to the principal axis and it comes out through the focus, or for a diverging lens, it appears to come from the focus. a ray through the focus, or for a diverging lens heading towards the focus, comes out parallel to the principal axis. And finally, this is the one that's slightly different, a light ray going through the centre of the lens continues unchanged, doesn't bend at all.